Hi everyone, welcome to another video from our inverse functions section of this series. Now we uncovered a few pretty significant ideas about inverse functions in our previous video. Now the first thing was the idea of this inverse based on what we know from where we've heard this voice before, this idea of opposites. Of things having opposite roles or opposite operations and things like that. We're going to examine this a lot further in this video. And we also talked about the idea of inverse functions, of the inverse function to one particular function is the same thing but reflected along this line of y equals x. So if I draw my grid here, my y equals x line, this one here, serves as a mirror for how the inverse function looks compared to the original function. Now, if I were to just draw a graph for this first example, we are going to look at sketching or graphing an inverse function as a reflection along this line, y equals x. So if I drew one particular function here, and here is, it cuts through the y-axis at the point 1, we want to sketch its inverse. So this is my original function. So this guy here is my function. And we can see that it is clearly a function because every one x value corresponds to one y value. And we can see this from what we mentioned before as this passes the vertical line test. So if I were to draw a vertical line at any point of this function, on this function, I'm only going to get the function crossing it once. Now if I just clear this, let's look at what a reflection along this particular mirror here would look like. Now you may want to turn your heads or something as you draw this and look at how you might visualize that. But let's just look at, for example, this particular section of my graph. So we can see it goes from almost touching our axis and it goes up our x-axis and it goes up to cut this point at 1 on the y-axis. Now if I were to draw its inverse, this idea of a reflection with this line being my mirror, I'm going to start down here and I'm going to move towards this particular point here. I've now drawn the inverse of my original function, or part of it at least. Now I'm just color coding these so we can track what's happening as we go all the way through. And now let's notice what's happening here. We've gone from, with my function, it starts almost touching the x-axis, goes up to 1 on the y-axis. My inverse function, let's actually label this now. My inverse function goes from really close to my y-axis and crosses the x-axis at the point 1. And now if we keep drawing this, if I wanted to, for example, map out this part, I can see that my other function, if I kept going with this reflection idea, is going to look something like this. Now, if you turn your heads and look at to like a 45-degree angle where you're to look at this axis of symmetry or this reflection thing, you'll see that our function, our inverse function we've drawn, pretty clearly looks like a reflection of my original function along this line of y equals to x. So through this lens of opposites, let's just look at some things we noticed between our function and our inverse function. So the first thing is, as my function Actually, let's write this in function notation just so we can practice. As my function f of x approaches the x-axis, so looking at this section down here, my inverse function around here approaches the y-axis. So my inverse function here approaches the y-axis. Another thing we notice, when my y-intercept of my function is 1, at that same point reflected is an x-intercept of 1 on my inverse function. Let's write that down as well. So when y-intercept of my regular function f of x is 1, in the reflection, my inverse function has an x-intercept of 1 also. So the same number, 1, but we're looking at the opposite here. So in other words, one main thing we can make an observation about with our inverse functions is that the roles of y and x have changed for my inverse function. So these are some pretty important takeaways when we look at something like this. So we noticed before this idea of opposites happening when we drew our inverse function. And the main thing we can sum up here is that the roles of y and x have changed when we compare the inverse function to the original function. And we can sort of clearly see this here when we've drawn it, when we draw this reflection here along the line y equals to x. Okay, so let's look at one more example, and here we're going to be finding an inverse function algebraically. So we found something graphically, we've practiced drawing it as a reflection along the line of y equals to x. Let's look at finding the inverse function algebraically. So we want to find the inverse function of y equals to 3x plus 4. So this thing here is going to be my function, and this is just a straight line. So we can pretty clearly see this is going to end up being a function, not a relation. So we said that to find the inverse function, the roles of y and x have changed. And we saw that in the previous video that we swapped the y and the x for inverse functions. So these two here, my y and my x, these have different roles for an inverse function. So when we write up the equation of my inverse function, these variables, y and x, are going to swap over. So therefore, for my inverse function, I'm going to get x equals to 3y plus 4. And we can make the, we want to make y the subject, because for all of these functions, when we draw them, y is always the subject. So let's do a little bit of rearranging here. I'm going to subtract 4 from both sides. So I get that x minus 4 equals to 3y. And I'm going to divide through both sides by 3. That gives me x minus 4 over 3 equals to y. Okay, And another way we can also write this, because we're looking at an inverse function here, instead of y, I'm going to use function notation. So I'm going to write the inverse function equals to x minus 4 over 3. Now another way we can write this is also x over 3 minus 4 over 3. If we want this as a line in our gradient intercept form. But this is pretty much the same thing. Well, not pretty much, it is the same thing to this. So these two are exactly the same. So this is how we can find it algebraically. We note that for inverse functions, the x and y have different roles. So we're going to swap them over first, then we're going to make y the subject. And when we actually graph these, if I go onto Desmos here, I've graphed all of these functions. And we're just going to confirm some of the observations we looked at before. So I have my original function, 3x plus 4 in red. I have my inverse function, y equals x minus 4 on 3, or x on 3 minus 4 on 3. That's in blue. And I've also included my reflection line, y equals to x. So if you tilt your heads here, you can pretty much see that these are definitely reflections along my line, my green line here. Now, noting a couple of other things, everything in my inverse function is going to be the opposite of my regular function. Remember, the x and y change roles. So if I look at, for example, the y-intercept on my line y equals 3x plus 4 on my original function, and I look at the x-intercept on my inverse function, the x and the y have switched over. I go from, first of all, a y-intercept on one to the same value but as an x-intercept, and I can also see these points are flipped over. The x and y's are perfectly flipped. I go from 0, 4 to 4, 0. And another thing I can see is in my other intercepts here. Here I have, for example, the x-intercept of my original function, y equals 3x plus 4. That coordinate is minus 1.3330 for the y. And in my inverse function, it goes 0 in the x to minus 1.333 in the y as well. So you can see once again the x's and y's are opposite. They are flipped over, which goes back to confirming the main idea we got from this video, which is that the role of x and y have changed for the inverse function. And that results in, when you draw something, it looks like a perfect reflection along this line of y equals to x. And also, this was graphically, for example, but when we look at this algebraically, we go about finding the inverse function in a very similar way. The x and y have changed roles, so we write them in place of one another. This is why we swap them up here, and we get something like this.